My name is Seppo Jaakola, and I'm going to talk about inconsistency in database clusters or in database replication topologies in general. It says MariaDB Galera cluster in the title. That's because I'm coming from the MariaDB conference in New York, and I was focusing in MariaDB, but Galera replication works also for MySQL, and as a matter of fact also with the PXE Percona XDB cluster. But first, a couple of words about my favorite topic, which is myself. I'm Seppo Jaakola. I'm one of the founders of Codership. We started to work on Galera replication in the year 2008, but before that we already worked with a number of other replication and clustering technologies, 3 different types. First was multi-master table-level locking cluster for MySQL 4.0 already back in 2003. Then working for Constraint, Unicluster Sequoia was something that we participated in, and when we started the Codership 2007, we first started to work for Tungsten Replicator, and our team actually developed it until release 1.2. And in this conference you actually can see the Tungsten. It's back again after being kidnapped by VMware for a couple of years, but Tungsten is now back stronger than ever. For Galera, we started to work on 2008, 2009. We already put out the first public releases, and probably the first that were in production 2010, and it has been growing pretty nicely since that time. How we work as Codership, our work goes for MySQL Community Edition. So we get what is published by Oracle there, and then we develop and make integrate our replication API to work with the MySQL Community Edition. And Galera replication component it's actually a plugin. It just plugs into any database server that is able to support this replication API. It does not need to be MySQL or MariaDB. It can be, for example, MongoDB, where we have also some work on the way. We work together very closely with MariaDB. We have joint R&D efforts with them. And the work that we do for MySQL Community Edition is then merged into MariaDB code base. And that's when you get to see the MariaDB Galera cluster after this merging is complete. Since 10.1, MariaDB Galera is already included in the mainstream MariaDB releases. So wherever MariaDB 10.1 is present, for example, the Linux distributions, you already have Galera in there, and you can start to use this cluster. It's about configuration, that you configure your MariaDB server to operate as a node in a Galera cluster, and then you are ready to go with Galera. And same progress will continue with future MariaDB releases 10.2 and 10.3, which are next ones in the roadmap. But in this presentation, I will focus on database inconsistency. We started to work with this replication Galera, already before that, starting 2003, and working with the customers and seeing what problem can happen for the cluster. And the worst of the problems is by far the data inconsistency. And that's why I'm focusing here to show that what it is, when it can happen, what kind of harm it does to your application, and how you can detect that, and how you can recover from data inconsistency. I will show a short run with the future Galera 4, where we are able to mitigate the problem of data inconsistency. It's never solvable. The problem has already happened when you see the data inconsistency, but you can change the behavior, how the cluster reacts to data inconsistency, and that's the last topic here, and actually that's the beef of the talk. I hope we have enough time to go there. First, in general, inconsistency in any database replication topologies, here is the usual MySQL asynchronous replication topology where you have a master and slaves and the replication flows to the slaves. Then you have clients who connect to master to read and write, and they can read from the slaves or maybe not use the slaves at all. So this is the usual thing. And if this system gets inconsistent, the only authority that you can trust is the master node. So you can just forget about your slaves and reboot them to steady state. And if the slaves nodes are not used for reading at all, so like kind of disaster recovery, then you are more or less safe. You just need to reinstall the slaves somehow and make sure that they are consistent from that point on. If you do reads to the slaves, then the application is safe from data inconsistency if you know that what you are reading and how you are using your reads. The only problematic situation is that if you are reading from the slaves and using those reads to justify what you will write to the master node, and that actually, if your use case is like this, you have the same problem that you will see in any multi-master synchronous replication topologies. And here is a multi-master topology like Galera cluster is 3 nodes here, and clients can connect to any of these nodes, read and write at will. Replication is more or less synchronous, usually not fully synchronous. Logically, when you look it from the application perspective, it looks like you have one big database, but you have several connection points, several IP addresses to your database server, and then you can connect from several sources to several targets there, but the data is shared and same for everybody. And if you add more nodes to the cluster, you just get more IP addresses where to connect to. So this is the logical view. And in this type of cluster, the effect of inconsistency is always immediate. And it causes problems right away. In asynchronous replication, so until the last version where you're reading and reading from slaves, using these reads to justify the writes, then you have the same kind of problem than multi-master synchronous cluster have always. So here, if one of the nodes is compromised, it has bad data, all the reads that come from there, they will lead to bad writes as well. And part of your the client cloud will operate on bad data, and actually this inconsistency will spread over to the whole cluster. When those clients start to write to other nodes in the cluster, you actually don't know what data you can trust and what you cannot trust. So this is why it's very problematic for multi-master clusters, and that's why you have to react very strongly if you suspect any data inconsistencies. What are the reasons why it can happen? In the beginning, the first and foremost reason was the state snapshot transfer, SST, as a shorthand notion. So this is the method of bringing a new node to the cluster. The cluster must donate the database state to a new joining node, and okay, here is your data, and you can start working from this. And if something goes wrong with this process of donating the database, then the starting point from the joining node is bad. And usually if there is a problem, it's so bad that the effects are immediate, so this joiner cannot even start. But the worst case is that there's just maybe one transaction missing, one row is wrong in one of the tables, and it will trigger the crash of this node later on. And it can be a long time, it can be days, it can be even years in some systems. And for SST, it has grown quite mature already. There are 3 variants, MySQL dump, rsync, and extra backup versions. And I would not suspect that they use anymore cause any data inconsistencies. It may be that they cause, and maybe some future version of cluster will bring some regressions, or it's possible to modify these scripts, and some people do it. There is an API for how the SST is being done. Cluster doesn't deal with the SST at all. It's just cluster synchronizes, replicates the transactions, but it just tells the nodes that you must somehow donate this node the correct state, and then I'm able to use it. And it's the responsibility of the script, SST script, to do the thing right. And there are scripts which have been modified manually for some purposes. And it may be buggy. There's a fourth variant coming from MariaDB, Maria Backup, which will be encrypted SST method. Cluster misuse is sometimes seen. Currently there are two easy ways to bring one of the nodes to be inconsistent. There's a session variable vsrep on. It requires super privileges. If you have those, you can use it for your session. And if you set this vsrep on equal to off, it means that whatever you do in your session is not replicated to the cluster. And with that, it's very easy to just spoil one of the nodes and cause problems with the cluster very easily. SQL login is native MySQL variable, and it has the same effect. It operates differently. It just skips bin locking, and if bin lock events are not generated, Galera has nothing to replicate. So the transaction looks empty from Galera perspective, and transactions happened in one of the nodes where your session went into, but nowhere else in the cluster, and then you are really in a big trouble very soon. More reasons: replication filtering sometimes happening, and quite often used feature that why does all the tables be present in every node in a cluster? Can you support replication filtering? And we did that. It was maybe a mistake, because if you do any of these replication filtering configurations, replicate do or skip bin locking, bin lock do or skip replicate do or skip, then certain tables or databases will not be replicated. But it's not honored when, for example, during SST, if you're using the default SST scripts, they will copy the whole databases all over the joining nodes. Even if you didn't want one table to exist in some of the nodes, you will get it through SST later on, unless you have your own SST scripts. And the other problem is with DDL, because DDL replication doesn't also look at the replication filtering. So if you alter a table and this table doesn't exist in one of the nodes, it will be replicated to all of the nodes as well. So these two reasons are more or less blocking a good use of replication filtering at all. Slave lag, I mentioned it here. It's not a data inconsistency, and I usually claim that there is no slave lag in Galera cluster, but there is some. There is a time window when a replication has not yet committed a transaction to other nodes, and if you're very fast to write and read the two nodes, it looks to you that these two nodes are inconsistent. And the final reason is the bug, software bug. It happens, and they will never be bug-free. And whenever more and more new features are coming to MySQL, those must be supported in replication, and problems may happen. And indeed, bug can cause data inconsistency, and has done that quite a lot in the early days. This is about the slave lag problem and how consistent reads can be done from the cluster. Galera has an inbuilt flow control, so whenever you replicate transactions, Galera makes sure that you cannot push too many transactions to the system so that not all of the nodes have been able to commit them. And this can be configured with the flow control parameters. We have limits that how long this window can be. By default, it's 16 transactions. So if you have pushed 16 transactions to the system and one node is not able to apply them, it will tell the other nodes to stop committing anything until I have catched up with you. So the time difference is more or less in the range of maybe 10 transactions that you can see. But if your client, so here is how it looks. We have a replication write sets coming to the system. So the 38 is the first one that is queuing up to the system. 49 is the newest one coming from some of the nodes. And these two nodes, you have client connections, one to this node and the other one to that node. This is transaction 42 and the other one is 45. And it's safe to use that. So whatever you read from there is consistent read. You can see all the reads up to the level 42. And you can do your business logic in the application because the commit order is the same for everybody. And you can do writes on this based on the information that you have read. The only problem is the time window here. So these 4 transactions are something that this has not learned about yet. And if it writes over these transactions, then there is a conflict and one of the transactions must yield, and in this case it's always the later one, so it cannot write. But the attempt to write was correct and what was read was correct and the business logic is correct. So it's not data inconsistency, it can look like that, but it's not it. And in this specific case, so the connections are only to one node. But then if you have several connections from one client, here this client is first connecting to other node to insert the data. So what we have here is we do an insert, write set is pushed to the replication queue. Replication will replicate it close to synchronous way. It's acknowledged by the other node, but not yet applied, not yet committed. And if you, at the same time, or very close to the same time, you try to read the same data, then you might not see it. And this is called, in research, it's called read causality issue. There's a causality between these two actions. So the client knows that I have done this, I have written this, therefore I must see the effects. And there are applications which do this on purpose. Some gaming systems, auction systems, for example, where there are, for example, several threads in the application side. One is doing writes and then it tells the other thread, okay, now I'm done, and you follow up from here, and it first checks that, okay, did he write it or not? And then he sees that he didn't write it, and then the application goes crazy and tells that this database is inconsistent. Then I got the call, and I have to go there and see that, okay, it's not inconsistent, but it's too fast reading. The same problem can happen even if your application is not multi-threaded and does not have this read causality dependency built in. It can happen if you are using some proxy, like MaxScale, with a certain configuration where the proxy can open several connections for one client connection. And then if you inserted something and try to read it, and if you are fast to do that, and MaxScale is fast to link all this configuration, and the cluster is slow to replicate at that point in time, it might be that you see the same problem, and then you probably have to do something for your cluster configuration. And what you have to do is to configure VSREP sync weight variable, which tells that your connection, your reads will be paused until the replication has reached a certain safe states. There are several variants that what kind of safe states today can be reached, and in the future a couple of more states there. And this sync weight variable is effective for read, selects, show commands, also transaction begins, and update and deletes also. And you can tell that what it's a bitmap variable, and you can tell that and it's also session variable. You tell that in my session, whatever, if you put all these flags on, whatever I do, select, show, begin, update, or delete, I will always wait until my slave queue is being flushed completely. And what it means in the end is that every of these operations is lower because there's always wait included. But what you read is does not cause problems for the client application which has read causality dependency. So the bottom line is that it's not data inconsistency. It looks like it. You can configure it with this variable to prevent this problem from happening for your application. It will cause delays for the application, and therefore you should use it only when you know that you need this. If you are using certain kind of proxy that requires this use, or if you have really a read causality depending application, then also go for this one. Some more problems or features that can look or cause inconsistencies: triggers, stored procedures, events. About triggers, they fire only in master node, and therefore they cannot cause any inconsistency. In MariaDB there is a variant where you can make the trigger to fire also in other nodes, but then you do this on purpose, and I would say that you are on your own if you do anything like that. Stored procedures also, they are immediately supported. I have not seen anymore for a few years any problems coming from stored procedures. Events, they can be a problematic, and it's one source of suspect if a system has events and it has inconsistency. They can be, in theory, they are supported. So the thing is that the events should fire only in one node in the cluster. But the problem is how do you define which is the node where it fires? In all other nodes, they should be slave side disabled. And a cluster is supposed to do that correctly. When you join a node, it will have from SSD it will have the event, and it should be slave side disabled. But the event should be enabled in some other node. If this node goes out, it should be automatically enabled in some other node. But does this process always work correctly or not? That's the question. And what you do inside the events, do you just, if you do any writes there, then there is a chance that something goes wrong. So triggers, the basic triggers which fire only in master node, stored procedures are all fine. Events can be suspicious, but should be supported. Foreign key constraints are supported. It was quite a long job to have them correctly replicated. And we enforce foreign key constraints in master node and in all the nodes in the cluster, and that's what we do. And any violation in the replication applying side, we also take it seriously. Actually, we crash a node which is not able to apply a transaction which fails a foreign key constraint check. Asynchronous replication, Galera can get in transactions through asynchronous replication, and Galera cluster can also fan out asynchronous replication. And for Galera cluster perspective, incoming transaction, it looks like client connections. They are in the same level, no bigger priorities. But there is one specific feature, pre-ordered configuration with the variable VSREP pre-ordered, and this was introduced for migration purposes where a cluster existing asynchronous replication topology would be migrated to be a Clara cluster. And then you can set the pre-ordered configuration where you tell the cluster that I can trust whatever is coming from this pipeline. And those transactions are good, and you can just apply them and not certify. Certifying is something that Clara cluster does for any incoming transactions to see that it is good and it's not conflicting with the work that I have done before. But this pre-ordered skips this certification phase. It makes the incoming transactions faster and removes one unnecessary point. But if you have that configured in your cluster, which also accepts client connections, then conflicts may happen and they are not dealt out with, and you may end up in inconsistent cluster after that. Then about the effects. In MariaDB and MySQL asynchronous replication, usually what you see is that, okay, SQL thread stops and there you are, and then you need to sort it out. And also skips certain errors with slave skip errors and so on. But for Galera cluster, it's totally different. The policy currently in Galera 3 and earlier is that if there is any problem with applying of a DDL statement, DCL or DDL, they are just skipped. So any errors, author table fails, that's not a problem. But any error in a regular data manipulation replication, it means your payload transactions, any problem of applying will cause immediate, we call it emergency abort. So the node that is not able to apply, for example, an update coming from the cluster will decide to make a quick suicide, and that's it. And same applies for foreign key constraint validations as well. And here is a free node cluster, write set coming from first node. It's possible to apply in the middle node, but here in the rightmost node there is a problem. How Galera reacts with it is it shuts down this server, takes it out of the cluster, and the remaining of the cluster continues the operation. From application perspective, what you see is that you lost one IP address where to do your business. But the cluster should be healthy about this. So this is the happy case if there was one node that was inconsistent for some reason, yet unknown. This node just goes away, and then you need to do your troubleshooting work later on to find out that why and how this could happen. What happens if you look deeper, this is the node where the write set was not able to apply. We pick up the error codes that MySQL complains about it, and we also write one specific file. This is shorthand for Galera, and with two numbers, the thread ID, which is the slave thread's ID that was processing this incoming write set, and the sequence number which tells the order of this write set in the cluster transaction history. And you will find this file in MySQL data directory. And the payload is the binlog events. And you can then just go ahead and see that what kind of transaction was not able to apply. And this is actually pretty good information for troubleshooting the problem. We get quite a lot of questions that can some transaction be neglected. For example, when I try to delete a row and it fails because the row doesn't exist there, and we get this reasoning that, okay, but what's the problem? The row is not there. It's just you are good now. It's already deleted, and you should accept it. or if you insert a row but exactly the same row already exists, somebody was able to do the same operation. And last is about if the cluster is already split and there is a node that is not a part of the cluster, I should be able to read from there even if it's not consistent. And quite recently we added this possibility. There is VSREP dirty reads variable. You can do it. I advise nobody to do that because you never know how old this data is. If you set these kind of variables always on, then you can, and you by accidentally connect to a node that is very historical, you're just reading there and you may make a big mistake. Then why we should not allow any inconsistency errors like delete of a row that did not exist. Here is a nice transactions that I would like to see but very seldom see nowadays when transactions are done by application frameworks. They look pretty dirty. This is something that you can see in telco applications where there are handwritten transactions. It has 5 statements first reads, and what happens in this read phase is that the application gets the knowledge about the state of the universe and then it runs its business logic, and based on these reads it decides to write exactly these writes. They are justified by the business logic. And then if there is any error in the replication, for example, if I try to delete a row, it means, and should I just accept it or not? It means that in this node, when I do this reads, the row is not there yet in this specific node. If some other applier sees the situation, it cannot delete the row, some other transaction before that is doing this, trying to read the row, doesn't see it. It runs the application business logic, and based on this information, this non-existence of this row, it has written something. And these writes are in some other tables in the system, and it's based on wrong reasoning. Therefore, the fact that we couldn't delete the row has already caused problems for the business logic, and this problem has spread somewhere else which we cannot track anymore. Therefore, the only correct way to behave here is just to stop everything and fix it completely and figure out that what went wrong and when, and stop it from ever more happening. Okay, the VSREP dirty reads, I already spoke about it. Finally, why DDL errors are neglected. We had to do it. I didn't want to do it, but there are quite many actually application frameworks, especially which do a lot of DDLs on the fly, just like that. For example, they like to drop a table which does not exist, for example, or something very stupid that just is not able to apply. And the way that we replicate DDL is we replicate it upfront, verbatim SQL statement. It goes to the whole cluster, and every node will just run this SQL statement, drop a table which does not exist. And if everybody would react like we do in Galera, is that we crash the node, then everybody would be just down. Foreign key constraints, I think that they are good in the way that they just enforce the business logic. They bring discipline to the database structure, and therefore they are only for good. And the replication system must support that. And in Galera side, we are encoding quite a lot of information of foreign keys, that how these references exist and what kind of transactions are safe to run in parallel. And we have read keys and write keys in the write set header where we encode the foreign key references. And based on this information, we allow and disallow certain operations for child and parent tables. Then how to recover from, if your database crashed, one node crashed, two nodes, maybe whole cluster because of the inconsistency. The fundamental way to recover is only SSD. You need to copy the full database, but the problem is that where to copy from, which node data I can trust. If it's only one node that is out and all the others are good, then your chances are good that, okay, I keep this cluster and force this one node to join with the SSD. But still you should investigate it. You should go and look at this specific transaction, why it failed. Take a look at the business logic that you have in your application and try to track that, was it actually so that this one node was correct and all the others were wrong. That can also happen. But it's a very hard problem. It's the hardest problem. And what makes it especially hard is that when you see this inconsistency, you don't know when the problem happened. Sometimes you can see that there was a transaction on the fly that caused it. That's a happy situation. You can track it quite easily. But if the inconsistency was brought a week ago, month ago, year ago, several years ago, just one table, one row that should not be there or was missing, that's a problem. And when the harm was in the database, there were applications that were reading it, made bad conclusions for their writes, and they are, it should be rooted out. And in this analysis, these dump files, they are very, very good, but quite often also application logic, application logs are needed for troubleshooting. There are some voices I heard that okay, but for example, if you delete a row that doesn't exist, and then should just continue, and this system is kind of slowly moving towards to a consistent state. And in multi-master topology, this is absolutely not possible ever to happen. It will just go worse and worse by time. But in master-slave topologies, in theory, some good progress might happen. You could accept problems of deletes and inserts and hope that eventually all the nodes will be the same. But updates will be the problem. We are replicating with row images, and there is a before image check and after image check. If you cannot find a row exactly with the same before image, you cannot write the after image there. If you trust on primary keys, relax this somehow. Look only at the primary key, forget about the before image bitmap, and then write over that row. What if the key was the problem and you're writing over a good data which just happened to have a key that is for the row that was not a problem at all? So I would say that any of these ideas of slowly migrating to a good state, they will never work. You need to just do the full copy eventually. How to detect inconsistencies? Is it possible? It is possible, and it's good because if you do it early on, if you have a way to kind of look at your databases periodically that are we consistent now, it gives you more time to react. as compared to a situation when you see the crash in a cluster, and when a crash happens, the DBA is in panic and runs in circles and screams, and it's not a good time for clever thinking then. But if you can detect the inconsistency with the, early on in a controlled way, then you can behave more rational way. But there is a problem in multi-master systems. There are transactions coming from several sources, they are being applied. How can I read from all of the nodes at the same time? And for this reason, we quite early on in the development of Galera cluster, we already implemented a way to do it. And the target was here to support a specific tool, PT table checksum, which does statements insert select and replace select. And Galera cluster, when it sees these two statements, either one to come in and having a magic comment in the end of the command line, then Galera cluster will replicate this statement to the whole cluster and make sure that they are processed at the same time, same transaction slot, and non-parallelly, so nobody is able to commit at the same time. So they will see the same read view. You have guarantees for it. And you can read from the same state, and you can then either insert or replace to somewhere else, and then later on you can go to see what you have learned from the database states. For here is one simple example. You just create the table like consistency with whatever information, checksum field for example, and then you do insert select. You are selecting from your table that you are suspecting to be inconsistent. It's my table here. You put this magic comment. In this example, you take MD5 sum of a couple of columns, and then you are populating your consistency table. And what happens is that in this cluster, the consistency table is here in every node. It's empty. Then you run this insert select to one of the nodes. Your command goes to the queue of incoming transactions to the system. 954 is the version number of that sequence number. When it's in the state that it has to be applied, every node will do it at the same time. They will not do anything with 955 at the same time. And they process the select and they do the insert. And after that, the cluster is back to operation, but you can go then to your consistency table to see that what I have inserted here. And the magic is that we do this insert select in the same way that we do for DDLs. We run it in total order isolation. Yes, it is automatic. You only need to have this comment. If you have insert select and this commit, this will happen in automatic way. It will have impact because it's blocking any commit. If the select is huge, you have millions or tens of million rows, and you want to read all the rows and do your MD5 checksum in the bottom, it takes a couple of minutes to run that. Nobody's committing at the same time. So then you are more or less pausing everybody else to do something useful. And for that reason, you should just take small chunks of what you are reading. PT table checksum has something like this implemented. It should operate in small batches, and it's quite automatic. It goes through all your databases, all your tables there, and will tell you in the end that was this consistent or not. And finally, the last topic, I have 5 minutes to go. I had a kind of demonstration, but time is too short, so I will just show the slides and the end results of how it goes. So today Galera 3 and earlier they will just crash the node that sees any inconsistency, and we came to the conclusion that this may be too harsh and some more clever way to react to it. And there are some vulnerabilities. It's possible to shut down the whole cluster. If you are evil-minded DBA, you can do it. You only need super privileges to do a trick like this. We have 3 nodes, node A, B, and C. Then we create a table in node A. So the table is there. It's replicated, DDL, total order isolation, it's all good. Then here we tell that we don't want to replicate this session. We can use SQL log bin or vsrep on equal to off, and then we insert one row, and the row is only here. It's not here and not here. Then we tell that, okay, we want to replicate now, and then we tell delete from T. The delete will hit this node. It will see that, okay, we have a road. We must build a write set with a delete event, replicate it, and make those guys to apply it. They try. They don't see the row. Therefore, they kill themselves one by one, and this happens quite at the same time. So it's a Byzantine error. All the nodes that will see this, flow control makes them to happen practically in one instance. And because they go out, this node is happy with the delete itself, but it sees that all my friends are gone. And actually I'm the only one here. And he thinks that those guys probably have a better cluster somewhere else. I'm not invited, and therefore I kill myself as well. And there you lost your cluster. And you can really do this. And I had a demo where I saw how easily it happens. To deal with this and inconsistency, or to optimize the way that Galera cluster in general works for inconsistency, we have implemented a consistency voting protocol for Galera 4 future version, where the target or the idea is that we take a look that when the inconsistency happens, we run a certain protocol where every node participates, and they figure out that what should we actually do now, not kill nodes at will. And here is how it goes. We do this bad transaction attempt through one node. It's replicated. These cannot do it, and then they start the voting protocol. They tell to every node that I got this error. What did you get? And in the end of this voting, every node will tell their results for this polling. It's a kind of polling. 2 nodes tell that they have the same error code coming, and the node A tells that there's no problem, and in the end result, this node A will voluntarily shut down, and these 2 nodes will continue running. Galera 4 has also one variable here for telling that what is treated as error. So now also certain DML errors can be accepted. And what this actually does, it doesn't prevent inconsistency, it doesn't cure inconsistency, it just changes the way that the cluster deals with inconsistency. So the cluster doesn't crash, DBA doesn't have to run in circles and scream, service is on, he can relax, but he must do the troubleshooting after all. And as a summary, data inconsistency is the most critical problem, and it's very hard to track down. Usually, in some cases, it's solvable, but there are cases when it's not even possible to tell that why this happened. It affects both master-slave and multi-master topologies, but the inconsistency is immediate. You will see the problem immediately. If you have a master-slave topology, the problem is there, but it's not surfacing at the moment. It's possible to harvest these and do your early on testing, PT table checksum, or manually. If you suspect a certain table and you know how to write SQL, you can just do it manually, a targeted query to the cluster, and then you can see that was it consistent or not. To recover, it's the only thing that really works is full database copy. So if you have a very big database sizes, you pay time here. Terabytes take 4 or 8 hours to copy over. It's the only way, because you don't know when inconsistency happens and you don't know what is inconsistent there. Maybe in the future it's possible to do scanning of these tables so that you can see that only one table is inconsistent and the rest is not. Then you can make, possibly it's maybe possible to do just a mini SST or something like that. But currently we don't have a work for this on the table. Yeah. And finally, Galera consistency voting protocol coming. It will help. It will not cure anything, but it helps how to react to that problem. That was the last slide and last minute. Yes, that is close to Barcelona, small village. There are many villages named for Galera. This is only one that I have been to. In Chile there is a train station called Galera. It's one of the train stations that people want to go to because the altitude of this train station is very high. It's the third highest train station in the world. So I happen to travel there. Okay, some questions? Yeah.
Well, thank you for the talk. I was just curious about the sync waits. I'm just wondering if you wait for all lower order messages to be delivered at the GCS server, or if you wait for the transactions contained within all lower order messages to be applied.
Yeah, this Galera 3 is waiting for the whole slave queue to flush. So you're waiting too much. But we have in the next version we will see the GTID of the write set that we want to wait for. So that work is coming. But currently you wait for the whole queue. When I've seen people using the sync wait, it's not a big problem. So because the flow control is so tight. But on the other hand, you can configure flow control to be very long, and then you must pay attention to it. Okay, I must stop. The next one is coming in. Thanks for listening.